Okay, let's begin. We are in chapter 1 of the book. Hopefully by now you've ordered at least your copy of Engineering Economy. It's going to be important for you to follow along this semester with the material that I teach you and supplement that with readings from the textbook. So we're going to continue talking about interest rates today and the effect of compound interest. And then we're also going to talk about weighted averages. So just to revisit some of the announcements, beyond getting the textbook, your first homework assignment is available on Blackboard right now, and that should be submitted before class next Monday. So I'm going to show you a couple of slides related to how I'd like you to submit that. It should be as a PDF file, a scan of your hand calculations. Later in the semester, you're also going to be submitting spreadsheets. And so if I've asked you to do calculations on Microsoft Excel, then you need to submit the Excel file and also your hand calculations. But these first few assignments are only going to be your hand calculations. And so here's an illustration of what I sometimes get from students who aren't yet familiar with how to make a good quality scan for their homework. And obviously the grader wouldn't be able to do much with this if it's out of focus and keystoned and blurry. I mean, it's basically illegible. So that's a bad example. Here's also a bad example. It's blurry, keystoned, the lighting is poor. And then another problem is that sometimes students will do their assignments on lined paper. And lined paper is good for maybe English essays, but it's not good for engineering calculations. And so in the course, I'd recommend that you just use plain copy paper with no lining on it, or engineering computation paper, which looks like this, and it has the grids on the back side of it, which gives you kind of a faint structure to follow if you want to. But then when you scan it, the lines don't interfere with what you're actually trying to write and show. So here's a good scan. The good scan is in focus, it's well lit, the contrast is good, it's not lined paper, it's been scanned to either grayscale or black and white, and keystoning is when it's taken the photo at an angle so that it's shorter on one end than on the other. So apps like Cam Scanner or Adobe Scan can do all of these things more or less automatically. You still have to put a little bit of thought into making sure the camera's directly above your paper. You have to make sure that you've got good light in the room. But aside from that, it takes care of everything else. And I wanted to point out with the screenshot of the Adobe Scan app that it's down here at the bottom where you can select filters and indicate that you want a grayscale scan. Grayscale is better than color because it enhances the contrast. And there's not going to be anything I ask you to do this semester where color will be important for the homework grader to see. So it's better for you to do either black and white or grayscale, so then that enhances the contrast. So does anybody have questions about how to create a good-looking PDF file? Yeah.
If we draw work like on an iPad, can we just take screenshots and put it in PDF?
Yeah, I know some people are maybe writing with a smart pen directly onto the screen of their computer, and you can't submit a JPEG or a TIFF file. If it's a PDF, then that's fine. But you don't have to take what you're doing on the iPad, print it out, then rescan it. That's not necessary. It can be like a direct export of your e-ink. So just a summary. Photographs, which are like picture extensions won't be graded because the reason for that is it's really a challenge for the grader to flip between those files. It loads very slowly in Blackboard. It needs to be a continuous single PDF file rather than multiple files. And please also present the problems in order. If you've got 10 problems on the homework assignment, the way they appear in the PDF file should be the order that they were assigned in the homework. And make sure that you're uploading it to the right class and to the right assignment. Occasionally, I may have homework 3 open and visible to you at the same time that it's still accepting assignments from homework 2. And so you need to be sure that you don't upload your file to the wrong location. So just be sure that you're submitting it to the correct assignment, that the file has all of the problems that you solved, and that once you upload it, you'll get a confirmation just to make sure that it went through and that maybe your Wi-Fi signal wasn't interrupted as you were uploading the assignment. And then just a reminder about what it says on the syllabus, that we have a late work policy in the course that prevents late submissions. And so please don't ask to submit late homework if you don't have it uploaded on time. And just a reminder that I'll drop the 2 lowest homework assignment scores from the semester when I calculate your final homework average. And so don't panic if you forget one time or if you get busy and you're not able to do all of the homework problems. It'll be okay because of that. All right, so let's continue talking about interest. Last time we did an in-class exercise where you practiced some calculations related to calculating interest. And interest rate and rate of return are effectively the same thing using the same formula with just a different perspective. So when we are looking at this notion of principal plus interest from the perspective of a borrower, then when we express the interest as an annual fraction of the principal that was loaned, then that's interest rate. But if we are looking at the situation from the perspective of the lender or someone who's investing in a opportunity to generate profits, then we'd calculate that same interest amount and call it a rate of return. So it's the same formula as we'll see here on the next slide, but just a difference in perspective, whether we're calling it an interest rate or a rate of return. So during the semester, sometimes I'll ask you to calculate the rate of return, and the hypothetical scenario will be that your company is going to make some investment and then it expects to get future profits. And so when I ask you to calculate the percentage associated with those profits, what you'll be calculating is the rate of return, because your company has been spending some money now to get future profits in the forthcoming years. But then sometimes you'll have some hypothetical scenario where your company or an individual has borrowed money and they're paying for the privilege of having borrowed that money, and what you'll be calculating is the interest rate. So here effectively is the same equation that you saw in class on Monday, that on Monday it said that the interest rate is some interest accrued per unit time divided by the original amount. So here the rate of return is the same thing. It's just a matter of perspective. And so after 1 year of interest accumulating, then how much you owe is the initial amount that was borrowed plus the interest amount. And the interest amount is based on the initial amount that was borrowed multiplied by the interest rate. So times 0, in this class, amounts and times are really important. And so what we say is times 0 is when some first transaction occurs. Like if you go to the bank and borrow money to buy a car, then now, today, when that first exchange of funds occurs is times 0, and then time 1 would be 1 period after now. So if it's compounding monthly, time 1 would be 1 month from now. If we're doing our calculations on an annual basis, then time 1 would be a year from now. Okay, so this is a figure which illustrates an important concept. And I'll take now to give you a preview of our exams. Just briefly, I'll mention our exams are usually about 65 to 70% of the points will be from you solving problems and doing calculations, but 30 to 35% of the points on the exams are related to conceptual understanding. So you'll have to write the answer like a short answer type problem. And so it's not all about crunching numbers in this class. It's about certain complicated concepts and some concepts that are really easy, but It's being able to understand the meaning of a concept and repeating it or putting it in your own words. And so here's an example of a figure that's important for you to know the why behind the figure. And this is a general trend that says when a company borrows an increasingly large amount of money, then the interest rate they're expected to pay is going to go up. So let's just look, for example, at this first instance of what if a company was borrowing $2 million for 5 years to finance some delivery trucks? So if they go to their lender and they want to borrow $2 million, the lender asks a 10% interest rate for the privilege of borrowing that money. But if it's the same company and now they want to borrow another $5 million on top of it, meaning that the cumulative amount that they've borrowed is $7 million. So if we go to the figure here, if they've borrowed a total of $7 million, you'll notice that the interest rate that the lender requires is now 15%. So the more the company is borrowing, the higher the interest rate from their lender. So why might that be? Now, if you're going to speculate on why would a bank require a higher rate of return as the loan amount goes up, it's the same amount of time. It's 5 years for each. Anybody willing to venture a guess? Yeah.
It's because they're risking more money not coming back.
Very good. He used a key term that we're going to talk about several times this semester. Risk. I've got it in bold here. Risk. So the lender has several different kinds of risk. And the first kind of risk we're going to talk about is default risk. They may not get paid. So if it's the same company and the same time period, why is the risk of not getting paid higher for $7 million under loan compared to $2 million under loan? It's the same company. Why is the risk higher?
It's more money.
It's more money, and so when you've borrowed more money, what do you have to do? You have to pay more money. And so it's harder to make a big payment than a small payment, right? So this company, whatever they're doing, we don't know what they're in the business of, but they have some book of clients, they've got orders, they have projected income, and what the bank has done is they've looked at this company's book of business, they've looked at their financial situation, and just made the assessment that maybe this $7 million loan is at the edge of what they can pay. And you sometimes see this in personal finance as well. It's not just companies. Some people get a little bit too ambitious on how big of a house to buy. So somebody's just graduated, they've got their first job, and now they want a 5-bedroom home that's 3,500 square feet. And the bank says, well, yeah, we'll loan you the money, but they have a hard time making the payment because it's almost all of their disposable income is going towards the house. And so here the trend is that when there's more risk, the lender requires a higher interest rate to compensate them for the risk. So if I gave you this figure and asked you to tell me a story about the figure, I hope one of the stories you'd tell me would be about the risk of default, which is that the lender may not get all of their money back. So just to review interest. Why is it you have to pay the bank more than they gave you? It's because of the time value of money. Remember that money in the future isn't as valuable as money now because prices will be higher in the future. So the $100 bill that you've got in your pocket right now, you could go and have a pretty good time with that. But in 10 years, you could still have a nice time, but you just wouldn't be able to buy as many things in the future, 10 years from now, because prices are always going up in the inflationary environment we find ourselves in. So the time value of money means that a lender is going to say, if you're repaying me with those future dollars that aren't as valuable, I want more of them than the present value dollars that I gave you that are very valuable today. You're paying me back with less valuable dollars in the future, so I want more. So that's part of it. That's part of why lenders require interest. It's partly because of interest rate risk. And this is something we haven't talked about yet. If I loaned you some money right now, and we agreed on a 5% interest rate, but then something happened in the economy, interest rates went up, and now tomorrow, what if all of the loans are being given out at 10% instead of 5%? I'll be kicking myself because I loaned you money at 5%, and if I had waited, I could have loaned it to somebody else for 10%. That's interest rate risk. That is, that if interest rates in the economy are changing, then the lender can experience some negative consequences if the rates go the other way. And it's complicated, especially with bonds. Later in the semester, we're going to talk about bond yields, bond prices, and you're going to learn how to calculate the value of a bond. So we'll come back to interest rate risk. There are several banks over the last year and a half that had failed because the interest rate being paid on bonds went up, which meant that the value of their bond holdings went down. And you may have heard about Silicon Valley Bank. It was in the news about a year and a half ago. It failed because as as bond yields went up, bond prices went down, and all of the bonds that they owned became less valuable. So interest rate risk is another thing that, you know, lenders in the back of their mind are just thinking about, what if interest rates go up in the future? I want to make sure that I can get as much money out of these people now because maybe I would have had a better opportunity in the future. That's called opportunity cost. That if you can only do one thing with your money, then the value of the next best alternative that you can't take advantage of is the opportunity cost. So time value of money, interest rate risk, and then we've also talked about default risk already. The borrower may not repay the loan. Maybe they'll repay none of it, maybe they'll repay some of it, but if you don't get the full value of what you're expecting back, then that's considered default. Any questions so far about the justification for interest from the perspective of lenders? So again, be prepared to define and explain these concepts. I like calculations as much as the next guy, but you also have to be able to explain ideas because that's oftentimes what will linger in your mind long term. You know, retention is important, and maybe you won't be able to do some of the complicated calculations a year from now, but I hope you'll be able to understand and explain some of these concepts in the long term. Okay, so simple interest is something that you're not likely to encounter in your life. Maybe your parents would give you a simple interest loan, but it's not common because you're not getting as much money, and lenders prefer compound interest. But the idea of simple interest is that the interest amount is calculated only taking into account the principal. So the formula here is that the interest amount is the principal multiplied by the number of compounding periods multiplied by the interest rate. And so if it's a simple interest loan and the principal is $100,000 and we've got 3 periods and it's 10% per year, then the amount which is due at the end of those 3 years would just be $100,000 multiplied by 3 times 0.10, so $30,000 for the interest, and then the total due would also include the principal. So that's a simple interest loan. We won't spend too much time on that because of how uncommon they are, but what's far more likely to happen anytime you borrow money is that the lender will want to have interest paid on the total amount which is due at the end of each period. So that means compound interest. So the compound interest says that the total interest amount which is due at the end of some time frame is the principal plus all the accrued interest. And so interest compounds over time. And let me show you what that compounding cascade looks like. So let's say, for example, that we want to find out the interest rate that's due in year T. So this formula, by the way, don't feel intimidated by this formula because all it's saying is that the interest amount that's due in year T is the principal amount plus all of the previous years prior to year T interest amount added together and then multiplied by the interest rate. So I is a rate, and if it's a percentage, then we'd express it as a decimal here. So if the interest rate was 10%, then for I we would put in 0.10. P, the principal, is the original amount you borrowed, and then this summation is just saying the sum of the first year's interest, the second year's interest, and so on, up until t minus 1. So if t is whatever year we're in, let's say the third year, then t minus 1 would say the first year's interest and the second year's interest added together. So this is the formula that we'll apply on the next slide to find out the interest that's due at time period t. So that same $100,000, let's say that it's a 3-year loan, interest is 10% per year. So the previous example we looked at was simple interest. This is compound interest. So the previous example said $130,000 would be due after 3 years. Let's find out when the interest is compounding how to handle it. So we'll do it 1 year at a time. In the first year, the interest amount is $10,000 because it's 10% of the principal. At time 0, the lender gives the borrower $100,000, and so then that instant is when the clock starts. They owe $100,000, and then at the end of the first period, meaning at the end of year 1, they owe the principal plus 10% of the principal, which is $10,000. So the total due at year 1, $110,000. So now during the second year, the interest that they're going to owe is not $10,000 again. In the second year, they owe interest in the total amount that they haven't yet repaid, which is $110,000. So in year 2, you can see that the interest amount is 10% of the previous balance, $110,000. So they owe $11,000 in new interest, which is added to the previous balance of $110,000. So now at the end of the second year, their tab is $121,000. And so you can detect that there's a pattern here. For year 3, the interest that's due is 10% of the balance at the end of the second year. So 10% of $121,000 means it's $12,100 of new interest added to the previous tab. And so at the end of the 3 years, the total amount which is owed is $133,100. So simple interest was $130,000. Compound interest is $133,000. So you can see why lenders prefer to have compound interest, because they want the interest to reflect the fact that they haven't been paid at the end of each year. So the total amount that you owe continues to grow and compound. So if you are loaning money, then compound interest is really powerful in your favor. Like if you have a savings account or a retirement account of some sort, then you can use this to your advantage. It's not only banks that get to harness the power of compounding. Individual investors can too. Later in the semester, I'm going to give you a project where I ask you to start thinking about your financial situation after you graduate and setting aside money for retirement, setting aside money for your expenses, and how those will grow over time. And so through that project, I think you'll see that if you have a solid financial footing, you can have millions of dollars by the end of the time that you are ready to retire. That's compound interest. Any questions about this illustration? So, at the end of the third year, if we were just going to use this formula, the interest that's due in year 3 would be the principal of $100,000 plus the previous interest amounts. So $10,000 was the first year interest amount, $11,000 was the second year interest amount. Adding it all together, multiply it by 0.1. So we can either do it sequentially, year by year, like this, or we can just plug it into the formula and find the interest amount in year 3 directly. All right. Sometimes when you are working with interest rate, you'll see these terms nominal and effective defined. And the way that you can keep them straight is nominal is kind of like not really. It's like an advertised rate, but it's not really the interest rate that you're going to pay because of the effect of compounding. So let me go into more detail. Let's say that you've got some quoted interest rate of 16% per year. So a lender is saying, our interest rate that you have to pay is 16% per year. But then they follow it up by saying the interest is compounded quarterly. That would mean every 3 months they do the tally of what you owe. And so the next quarter, you're going to have to pay interest not only on the principal, but on the previous interest that's accumulated in the prior quarter. So when it compounds within a year, interest rates are usually expressed in terms of an annual time frame, but the compounding frequency can be more often than on an annual basis. And so that's what nominal versus effective is all about, is just our custom of describing interest on an annual basis, but then lenders oftentimes will have compounding either quarterly or monthly or even daily in some cases. So in this example of 16% per year, what that means if it's compounding quarterly is that it's actually 4% interest rate per period, each quarterly period. So the effective interest rate is going to be the actual interest rate that takes into account the fact that the interest compounds within the year. So here's the formula for how we can calculate the effective interest rate based on a given nominal interest rate. So I, on the left-hand side of this equation, is the effective interest rate, and R is the nominal interest rate expressed on a per year basis, M being the number of compounding periods. And so let's use that example of 16% nominal interest rate per year, but it's compounded quarterly. So if we start with the formula of I equals 1 plus R divided by M to the power of M minus 1. So R is 0.16, M is 4. So we'll just substitute in. It's 1 plus 0.16 divided by 4 to the power of 4 minus 1. Okay, so 0.16 divided by 4, that's the same thing as saying 1.04 to the power of 4 minus 1. So that is 1.169858 ... minus 1. By the way, what do you think I mean when I have these dots after the numbers? It means it's a long number that continues. I haven't shown all of the digits that exist. Rounding off will be important in this class. Most of the time we're going to want to express answers to the nearest penny, so we can't get sloppy about rounding off in the middle of our calculations. We'll round off at the end when we figure out how many cents it is. So here I'm just, with the ... saying I've still got those numbers in my calculator, but I'm not going to write all the digits that my calculator has on the board. So anyways, 1.169858 minus 1, that is 0.169858 and so on. So that's 16.99% is the effective interest rate. So the nominal interest rate is 16% per year, but if we have compounding during the year, then the effective annual interest rate is 16.99%. Just remember the formula, and we'll get some chances to apply it in today's in-class exercise. All right. One last kind of conceptual illustration before we talk about weighted averages. This is yeah, do you have a question?
On our homework, would you want us to do the ...
I think it's a good habit to do that because it'll communicate to me or to the homework grader that you haven't rounded things off prematurely. It'll be a good way to show that, yeah, I still have all this precision in my calculator as I'm moving forward. So yeah, adopt that. Okay, the picture that's on the screen here, it's two rivers coming together. Which way is the water flowing, by the way? Is it flowing from the top of the screen downward, or is it flowing from the bottom of the screen upward? Anybody know which direction the river's flowing?
Down.
It's flowing down. Yeah, it would be ridiculous for it to be flowing up, right? Like there's some river that just like all of a sudden separates into two different colors. So yeah, it's flowing down. So it's a river from a really muddy geography where there's lots of turbidity in the water, and then a river from an area that probably has more rocky geology. Maybe there haven't been as many thunderstorms, and so the water is less turbid, this river on the left. And I don't know where this is, but the point I want to make is that when you mix things together, you don't always just add the two quantities and divide by 2. The amount of each river would be what you need to know if you were going to calculate the concentration of turbidity in the finished mixed river. You'd want to know the flow rate of river A and the flow rate of river B, and take into account the amount of each thing and calculate a weighted average. So that's a physical illustration of a weighted average. A weighted average takes quantities into account rather than just a simple average, which is where you add them together and divide by 2. So in money, this, by the way, is a rearranged slide from the next lecture. I just dragged it forward because I wanted to introduce this formula today as well. A weighted average in terms of money, it is the value of something. It could be an interest rate. It could be milligrams per liter. It's a value of something and then an amount of something. So it could be, if we're talking about a river, it could be cubic meters per second, like a volumetric flow rate. Or if we're talking about money, it could be how many dollars from a certain type. So if we want to calculate a weighted average, just as an illustration, what if you had money in two different accounts? You had one account that pays 10% interest and another account that pays 2% interest. So if you had those two accounts, you'd probably keep more of your money in account A. And that's the case that's illustrated here. You keep $5,000 in account A because that's the one that pays the most interest. You keep $1,250 in account B, which only pays 2% interest. So the question is, what's the weighted average? The average is not 10 plus 2 divided by 2. That would be a simple average. A weighted average takes into account how much money do you have in each account. So it's going to tell you your overall interest rate that you're earning by saying we'll have 10% is what account A is earning, multiplied by the amount that's in account A, which is $5,000. And then we have 2% being paid by account B and $1,250 there. And then you divide by the total quantity of dollars that are in both accounts, $6,250. So the weighted average is 8.4%. So that's a weighted average. You'll see it in a lot of different classes, but you're seeing it in here as well. So we can do it with 2 different things being combined together. We can do it with 3 different things being combined together. So like here in this formula, it's saying you'll take an amount, a value of category A. In our case, it could be interest rate. And by percent of A, I just mean like the total percent of dollars that are allocated to that type of investment. So we could use like total dollars, which was what we did on the previous slide here, dollars of A. You could also express it in terms of percent of the whole. In the in-class exercise, I'm telling you some amounts on a percentage basis rather than on a dollar basis. So you'll have to calculate something called the weighted average cost of capital. like if you're borrowing money from 3 different sources and you want to know what's the average interest rate you're paying, then you have to know how much money you've been borrowing from each of those 3 different categories. And this is the approach for that. So let me hand out the in-class exercise for today. We've got 15 minutes to take a look at some of these problems. And by the way, if there's any extras, when it gets to the end of the row, just pass it back. I'm not going to bother counting these out. So the answer to problem 1 is $432,000. The answer to number 2 for part A, 31.89% is the effective interest rate, and then if you have daily compounding, it should be 32.3% interest rate. I just put the answer to problem 3 up on the screen if you want to check on that one. Reminder, I record this video and I'll post it on YouTube, so if you need to take a second look at the solution, just check the video, which will probably be posted within the next hour or so. And I'll put a link to my page on Blackboard. It's easy to find, but I'll link it on Blackboard. So for part 3, you could have calculated the amounts, or you can just leave it as the percent of the amount. So for example, the bank loan, which is 6.5%, it's either 25% of the amount that's borrowed, or you could calculate how many dollars are you borrowing from the bank. You could leave it either way. It's an expression of amount. So the weighted average cost of capital is 5.99%. Problems 4 and 5 are just kind of looking ahead to the future. You can think of them as maybe bonus problems, where I'm giving you a hint of a simpler way to calculate the effect of compounding. You know, this way, we just did it year by year in rows. And when we're using spreadsheets, that's fine, because spreadsheets calculate very quickly, but it's tedious to do it one row at a time by hand calculation if you've got a lot of years. Whereas these formulas, which I present in problems 4 and 5, future is equal to present times 1 plus I to the n power. That's a way of accounting for the effect of compounding. So you'll see that if you borrow $85,000 today, the interest rate's 9.5%, then the effect of 3 years of compounding is that the future value of what you owe is $111,000, 599.25. So that's much simpler than doing it the row by row method calculating the effective compounding. So we apply a similar formula in problem 5, this time calculating I, which is a little bit tricky because we have to isolate it algebraically, or if you have an equation solver on your calculator, you could just put it into the formula and have it solve for I. But it turns out the annual interest rate in that problem 5 is 4.97%. So that's it, 12:50, we're out of time. I'll see you in class on Friday.